Welcome to the Foundry by Forge College. So, if you hung out with us for the last explainer, Introduction to Network Selection, you know we laid down the core theories for navigating Solana's environments. Well, today, we're taking those concepts and turning them into a practical, no-nonsense blueprint. We're putting Mainnet and Devnet head-to-head, so you know exactly where to build, test, and deploy, without, accidentally bankrupting your wallet in the process.
Let's get right into it. Think of Devnet as your ephemeral sandbox. It's this super forgiving crash test facility. You can build completely wild, chaotic structures, smash them to pieces, and just walk away. Because hey, the memory gets wiped clean anyway. But Mainnet, that's the live ledger. It is an unforgiving, high-stakes, multi-lane highway where literally every single action has real-world economic consequences. So yeah, think less sandbox and way more Mad Max Rush Hour.
All right, here's our blueprint for today. We're going to hit the network selection trade-off, check out the 5 decision axes, map those to some real-world scenarios, figure out switching RPC targets, and finally wrap it all up with the final rules. Section 1. The network selection trade-off. Choosing your testing grounds. Let's dive right into this fundamental push and pull of every Web3 project, trying to balance the need for rock-solid, production-grade permanence against the very real demand for rapid, low-cost iteration.
We'll start with the heavy hitter, Mainnet. This is the live ledger. It's where your code meets reality. Transactions here are completely final, and they carry real economic weight. The fees aren't just simulated numbers. They're dictated by actual network congestion and real market dynamics. But most importantly, historical state here persists forever. Every single transaction, every state change, it's permanently etched onto the ledger. No takebacks. Now, completely contrast that with Devnet. This is your ultimate zero-consequence playground. It has low or even zero fees, which is absolutely perfect for rapid development. But there's a catch, right? It suffers from frequent, complete amnesia. The network is totally optimized for developer throughput, which means data is routinely wiped. You can iterate at absolute lightning speed, but just don't expect your data to still be there after you get back from lunch.
Moving on to Section 2, the 5 decision axis. This is your engineering checklist. Because we really want to move beyond fuzzy preferences like, I'll just test it where it's easier, right? We need to draft out the crucial engineering metrics required to make repeatable, confident deployment decisions.
So, let's separate these environments across 5 specific axes: stability, cost, data fidelity, persistence, and accessibility. Look at the stark contrast here. Mainnet gives you this unshakable foundation with high stability and broad access for external explorers and oracles, but obviously it comes with real variable costs. Devnet, meanwhile, gives you those sweet zero-toll roads and fast iteration, but its stability is intentionally low, like it might just restart or upgrade without any warning at all, and its data is entirely synthetic. So, how do we actually use this? Treat that table like a mental checklist. You map your specific engineering task directly to those axes. If your task absolutely requires a high metric in stability, fidelity, or persistence, then boom, you must deploy on Mainnet or a production-like testnet. But if your task easily tolerates a low metric, Devnet is your fastest, safest path. And by the way, in all of our structured learning programs over at Forge College, we heavily emphasize applying repeatable frameworks exactly like this to just completely remove the guesswork from your engineering pipelines.
Section 3, real-world deployment scenarios, where code meets the road. Let's see how this actually plays out when we map our 5-axis checklist to some concrete, real-world situations.
We're going to tackle 3 totally different scenarios: automated integration tests, load testing and profiling, and finally, analytics and auditing. This is going to perfectly illustrate that progression from the absolute safety of the sandbox straight to the demands of the live highway.
Scenario 1. Integration tests. When you're validating business logic or contract interfaces, Devnet is unequivocally your best friend. You avoid paying fees, you can spin up thousands of accounts instantly, and you iterate without a single production consequence. But you got to keep your engineering hat on here. Because Devnet resets and has different block production dynamics, it can totally mask subtle timing quirks that will absolutely bite you once you hit Mainnet. So use it for sure, but know its limits.
Scenario 2. Load testing. Okay, huge warning here. Load testing on Devnet is like trying to test the top speed of a sports car in a total vacuum. It just doesn't make any sense. If you want to measure throughput under realistic fee pressure or see how your order matching logic actually behaves in a congested mempool, you absolutely need Mainnet-like conditions. Devnet will yield dangerously optimistic latency and cost figures simply because its transaction prioritization and fee markets are entirely synthetic. Scenario 3. Analytics and auditing. Just imagine building a massive compliance report that aggregates user activity over 6 months, only to watch it spontaneously combust because Devnet decided to do a routine reset. Yeah, no thanks. Your entire analytics pipeline will break the second the underlying state is pruned. So for auditing, compliance, or historical data crunching, you absolutely require Mainnet's unbreakable memory and guaranteed data persistence.
Section 4. Switching RPC targets programmatically. Coding the switch. So here's the crucial point. How do we actually navigate these different environments as developers without having to manually rewrite our connection code every single time we run a test?
The secret is parameterizing your RPC endpoints. Here's a standard step-by-step for doing this cleanly. First, you import your connection and cluster API utilities. But instead of hard-coding a URL, you read your target network from a generic environment variable. From there, you establish deterministic RPC URLs based on whatever that variable outputs. This way, your continuous integration pipelines can instantly switch the target on the fly, and your actual program logic stays completely untouched. This might seem like a simple trick, but it is a massive operational win. By parameterizing endpoints, you can easily branch your logic and isolate those economic-sensitive tests. But here's the real pro tip. Always log the active RPC endpoint and the commitment level in your CI pipelines. When an environment difference inevitably causes a test to randomly flake out, having that active endpoint clearly printed in your logs will reduce your debugging nightmares from hours down to literally seconds.
Section 5. Final rules for developers. The master blueprint.
All right, let's roll up the schematics and summarize the absolute core principles of network selection that we've drafted today.
Here are your 3 non-negotiable takeaways. Rule 1, always match your task requirements directly to those 5 axes. Rule 2, Devnet is your best friend for fast iteration, but never ever trust it for cost or performance testing. Just don't do it. And Rule 3, keep your code modular by making your network targets explicit and totally configurable. In our next explainer, we're going to take this exact master blueprint and put it to work. We'll be applying network selection to use cases. To get ready for that, I want you to pick 2 features from a dApp you're currently building and try mapping them against the 5-axis checklist we just covered. Seriously, it'll completely change how you approach your deployment strategy.
I'll leave you with this thought to ponder. Is your dApp truly ready for the unforgiving, real economic consequences of the live mainnet? Or are you still just building sandcastles in Devnet? Think about it, run your code through the matrix, and upgrade those engineering standards. If you want to continue this journey and master these concepts, definitely visit forge.college to learn more about Solana deployment, architecture, and a whole bunch of other Web3 engineering topics. Thanks for tuning in and keep building.